Number one. Number one. Can somebody read that to me? What is it saying to do? Evaluate. Thank you. That's a good word.
From 2 to 6, find the area of 1/2.
Okay, that's what we're doing, but what's the calculus words? We are taking the integral of 1/2 x in respect to x, that's what the dx means, in respect to x, from the lower bound 2 to the upper bound 6, right? Okay, so to get a good grasp of these, you've got to be able to graph. So we're looking from 2 to 6, and we're looking at the line 1/2 x. What's the y-intercept? 0. And it's got a slope of 1/2, so it's just going to do something like this, right? And we're looking at the region from, let's say this is 1 and this is 2, 3, 4, 5, 6, whatever that is. We're looking at the region that's bounded from 2 to 6. So we're looking for this area. We don't care about this area anymore. You guys okay with that? Okay. We're not approximating. We're finding the exact area. So do you know how to find the area of that shape? It's a what? It's a trapezoid. You could cut it into a rectangle and a triangle, and that's fine if you do for now, but later on you have to know the formula for the trapezoid because we are going to do trapezoidal approximations in the same way we did rectangular approximations. So you need the area of a trapezoid.
Like cut it into trapezoid?
Right. So it's a good practice to know the area of a trapezoid. What is the area of a trapezoid? One-half b1 plus b2 times height. Okay. Now, this trapezoid is laying on its end. The bases are what? The trapezoid always has, what does bases mean in a trapezoid? They're parallel. So normally we see the trapezoid like this. We're stacking on its end. The height is what? The distance between the two parallel bases, right? So what is the distance between the two parallel bases? 4, because we subtract the 6 minus 2, right? So 4. Now, we've got to figure out what B1 and B2 are. How do I figure those out? I got to figure out that height, and I do that by plugging in 2 to the equation, right? So we'll say, I'll just show it here. 1/2 times 2 is 1, so we know this is 1. I know that's elementary, but you know. And this point is 1/2 times 6, which is 3. So we know this length here is 1, this length here is 3, this length is 4. We don't care about the diagonal. So we have 1 plus 3 for our bases. So we got 1/2 of 4 times 4, which is 8. So we can say the integral from 2 to 6 of 1/2 x dx equals 8. You guys okay with that? All right. Number 2. We want a function so that when I do a right Riemann sum, a right-hand rectangular approximation, we get an overestimate. So we want to have a curve, and you can just experiment, but either way, you wrote it down. What determines whether it's an over or under approximation? Whether a function's increasing or decreasing, right? So I'm just going to quickly do this. There's, let's see, there's an increasing function. There's a decreasing function. Concavity has nothing to do with it. So if this is increasing and I do a right Riemann sum, let's just cut it into 2 rectangles. Am I going to start here and go that way, or am I going to start here and go that way? I'm going to the right, from the right to the left. From the right to the left. That's a right Riemann sum, right? On this one, if I'm going a right Riemann sum, do I start from the left and go to the right, or do I start from the right and go to the left? So that and that. So what makes a right Riemann sum an overestimate? Increasing. So my answer will be any function that is strictly increasing. Are we good with that? Okay. Okay. We didn't quite get to this yesterday, right? I said I would keep talking, and I kept talking, and I didn't finish it up, so make sure we get this, okay? Remember back from geometry, the area is always positive, right? Just like length is always positive, right? But when we're talking about calculus, yes, area is still always positive, but the integral could be negative depending on where the curve is. Okay? The integral doesn't just mean the area, it means the area with a sign. Just like, what comparison can we make in previous calculus concepts? What else where one thing is always positive and the other thing could be positive or negative? Velocity and speed. Speed is always positive, but velocity is, it's basically the same thing as speed, but the direction implies what the sign is, right? Well, in integrals, the area is always positive, but the integral is always determined on where the function is lying, okay? So, if a curve is above the x-axis, so all of these are above the x-axis, we could say the integral is positive. Okay? Got that? Did you all write this down already? No. Some of you? Okay. And conversely, if it's above or if it's below the x-axis, then the definite integral is negative. Okay? So I'm not going to dwell on that too much, other than to look at the graph. So here's a graph that has regions that are above the curve, above the axis, and below the axis. So what is an integral equation that I can write that gives me a positive answer? Remember, the integral is from a lower bound to an upper bound.
So from like 0 to a.
Okay, so tell me what to write.
Little fancy s.
Integral.
And then at the top an a, and at the bottom 0, and then whatever that function is, and move dx.
Okay, so we would say, let's just call this f, I guess. We would say the integral from 0 to a of f of x dx is positive, right? Give me an equation that would give me a negative answer. Oscar?
Integral sign upper bound is e,
Mm-hmm.
and lower bound is a, and f
dx, okay. So the integral from a to b of f of x dx is negative. Notice how I'm saying it. The integral from the lower bound to the upper bound of the integrand, and then the variable of integration. And then the last one would be the integral from b to c of f of x dx is positive. And then I posed this question yesterday. I said, well, what happens if I took the integral from 0 to c? We're going to talk about rules later, but if I'm looking for the integral from 0 to c of f of x dx, if the curve represents f, how would we know if it's a positive result or a negative result?
You do 0 to a, and a to b, and b to c, and then you add values together.
Yeah, you'll add them together, and if the positive region is greater than the negative region, it'll be a positive answer, right? If the negative region is greater than the positive region, then it'll be a negative answer. Are we good with that? Okay. So let's look at a few examples. I'm going to give you 5 minutes to try and work these out.
plus base 2 times
All right. Number one, if you need to look at it graphically, we're going from -7 to -7 to 5, and it's a constant, so it's 6 up here, and we're going from -7 to 5. Okay. Notice how this is reading. We're going to get into the rules later, okay, because we could flip the limits of integration, and it means something different. Okay. But we are going from -7 to 5, and -7 is below 5, right? So there's nothing to worry about. How far is it from -7 to 5? It's 12. So that's the base. What's the height? 6. So then we would say the integral from -7 to 5 of 6 dx is equal to 12 times 6, which is 72, right? Okay. Number 2, it's the same thing, but what do we notice? The function is below the curve, so -3 here. And we're going from 1 to 5. Again, we're going from the lower bound of 1 to the upper bound of 5, so how wide is that? 4. Now this is how you can think about it, why it gives you a negative number. Because what is the height? Well, technically the height is 3, but it's in the negative direction. So we could say it's negative 3. So we'll say the integral from 1 to 5 of, what was it, negative 4? No, negative 3 dx is equal to 4 times negative 3, which is negative 12. You guys okay with that? Number 3, what do we have? We have a triangle. So y-intercept of 0, so it's like this. And we're going from 0 to 4. So we're looking for this region here. And again, we can think of this in whatever way we need. What is this length from 0 to 4? It's 4. What is the length here? It's whatever this value is, right? So I'm going to plug in 4, I get negative 4. So then the area of the triangle is 1/2 4 times negative 4, right? So that'd be negative 8. So that is the integral from 0 to 4 of negative x dx. Negative 8. Okay. And then 4. What do you guys know about this one? It's a semicircle. The function is a semicircle with a radius of 3, centered at the origin. So this is negative 3, this is 3. I am looking for the integral from 0 to 3, so I don't care about that part of it. Right? So the integral from 0 to 3 of that gross thing, 9 minus x squared dx, is equal to 1/4 of a circle. What's the area of a circle? Pi times, what's the radius then? 3 squared. So that would be, what, 9 over 4 pi? Are we okay with that?
Yeah.
Okay. Just a side note, if I were to say find the integral from 0 to 3 of negative radical 9 minus x squared dx, what is that function? That's the bottom half of the circle.
Does the number, if there's a number in front of the radical, that determines where the circle is oriented around?
No.
It has to be like x squared, or x plus 3 squared.
Yeah, the equation of a circle is x plus h squared. X minus h squared plus y minus k squared equals r squared. So whatever that derives to get y by itself. We're not going to go too far into that, or at all. Number 5, what is that? The function is a line with a y-intercept of 6 and a slope of 2/3. So I'm going to go up 2, which is 8, and over 3. That's actually where I want to end. And I'm going to go back to negative 6. So what point is that? If I plug in negative 6, I get negative 12 over 3, which is negative 4, plus 6 is 2. Okay. So 2 there. So we have this thing. We got a line. And we're looking for the integral from negative 6 to 3, so it is a trapezoid. So we would say equal to 1/2 of base, well, what is base 1? 2, right? Plus 8. And then what's the height? It's a distance across here, so 9. So that would be 10, half of that is 5, so 45. So the integral from negative 6 to 3 of 2/3 x plus 6 dx. By the way, just a very important side note, because last year I saw this all the time. This dx has to be outside of the whole integrand. So do not forget, if the function itself, the integrand, is a sum or a difference, that you put parentheses around that integrand. Okay? You don't have to do it here because it's just a constant number, or there. But here, because we have a sum, the dx is kind of distributing to both of those. So you have to make sure the parentheses is in both. Is that okay? Yeah. Okay. So let's see if I was right. 72, negative 12, negative 8, 9 over 4 pi, 45. Cool. All right. How much more difficult do we want to make it? A lot more? Let's see what we have here. I think you guys can do number 1. So we'll skip that one. Let's just try number 3. You guys can do number 1 and number 2 on your own. It'd probably be a good idea. Do number 3. If you can, yeah. Think of discontinuities. Where is there a problem? At 2. What type of discontinuity is it? What types are there? Removable? Infinite? Jump, I heard somebody say. And there's that oscillating one that we don't talk about, right? All right, I know you guys are working on number 3, but I want to go over 1 and 2 just real fast so you have something to look at. The first one is a line with a y-intercept of -1, and notice the region is all on the left side of the y-axis. So let's see, y-intercept is -1, and it has a slope of -1, right? This will be interesting, I think. So like this. Maybe I should have had you guys do this one too. You guys follow me? Let's figure out the, yeah, this is a good one. You guys please pay attention to this one. I'm sorry, I should have had you guys do this one. At -4, what is the height here? Oops, 3, okay? And all the way to 0, so what's the height at 0? It's -1, right? Now, we are looking for the integral from -4 to 0. Any ideas?
Make 2 triangles. No, a trapezoid and triangle.
Remember, the regions that we're talking about are bounded by the x-axis. So you're not going to draw a triangle that goes below the x-axis. Okay? You're going to say this triangle, and then you have this triangle. You follow me? You're going to add them together, but what kind of answer are we going to get right here? A negative answer, right? So I'm going to break this down to say it's the integral from -4 to what point matters? That one, right? Wherever it crosses. What is it? -1 of -x minus 1 dx plus the integral from -1 to 0 of -x minus 1 dx. You okay with that? Okay. We're basically breaking it down, and we're going to get into the rules, I think, tomorrow. The integral from -4 to 0 is the same as finding the integral from here to here, and then adding it to the integral from here to here. As long as you don't have any gaps or overlapping, you're okay. The end of this integral is the beginning of that integral, so we're good. Okay? So what is the integral from -4 to -1? What kind of shape? So it's 1/2. What's the base? So that's -1. It's 3. What's the height? 3. Plus, what's the shape? It's 1/2. What's the base? 1. What's the height? The height, right? It's -1. That's where the negative comes into play. So we would say this is what? 9/2 minus 1/2, which is 4. Okay. That's not the area. That's the integral. If you were going to say, what is the area, you would say the area of this plus the area of this. But the integral of this piece is what? Is negative. The area of this piece is positive, right? See the difference here? This is the integral, it's not the area. Are we okay? Kind of? I don't know. Number 2. Do you guys know what that graph looks like? It would be a V if it was just absolute value of x. It's absolute value of x divided by x. Kind of. What's x divided by x? 1. The top x is always what? Positive. The bottom changes signs depending on... Right? There you go. So it'll be something like this. Right? And I think it's open here. Something like that. Actually, it's open both because it's removable. Okay, or it's a jump. Okay, so we're going from what? -1 to 2? All right, this should be easy enough then. What is this area? What is this area here? This is -1, this is 1. This is -1. No, no, no. We're reading from -1 to 0. So this is 1, and this is -1. So the integral is -1. What's the area? 1. The integral is -1. What's the area? 2. What's the integral? 2. So the integral from -1 to 2 of, what is it? Absolute value of x over x dx is going to be -1 plus 2. All right. 3. We have a function that says x squared minus 4 over x minus 2. What is that shape? At first you go, I don't know what that looks like. But what can we do? We factor, so this becomes x plus 2, x minus 2. This is x minus 2 on the bottom. So those reduce. So we have a line with a removable, not a hole, removable discontinuity at x equals 2. Okay? So our line is up 2 with a slope of +1. And we have a hole at a removable discontinuity at 2. Which is what? What is the height there? 4. It doesn't matter. Because we're going to 3, right? Okay, what's the height on the 3? 5. And so it's a trapezoid. So it's 1/2 of base 1 is 2, base 2 is 5, and the height is 3. So 7 times 3 is 21, so 10.5. This is the height of the trapezoid.